Okay, I just need to, switch on the YouTube thing. Okay, so the first thing we're gonna do is basically it's called momentum, and momentum basically is the product of mass and its velocity. All right. Okay, wait a second. Who's making so much noise? Safir, you're making so much noise. Ramin, why are you late? Okay. So momentum symbol is P, and the basically it is written as momentum equals to mass times velocity. The SI units are Newton second, okay, or you could say kg meters per second. They're the same. Now you should remember, and this is the most important thing, that momentum is a vector quantity. Vector means it has a specific direction, okay? Now, so then we should look at the change in momentum and see that basically if you have an object which has a mass m and it is going at a velocity u, so if you apply force F onto the object for some amount of time, so for that period of time the object is going to change its velocity to some other velocity. So basically you will have an initial momentum which will be equal to mu and a final momentum which will be equal to mv. So now if you want to find the change in momentum is always final momentum minus the initial momentum. So then it will be mv minus mu. Is it clear, everybody?
Yes, sir. Yes, sir.
Okay, please write this down. Okay, now So now let's do an example and see what I mean by this. So suppose it says that there is a wall and a molecule of mass m is traveling with the same velocity u, hits the wall, and then returns with u again with the same velocity. Okay? A molecule of mass m hits and rebounds backwards at velocity u. It says find the expression of change in momentum. Can you please do it? Get me an answer, please. Interesting. Okay, you guys are done?
Is it 0?
0? Okay. Okay, who else can answer me? If she's right, please tell me she's right. Ramin? Is it 0? Safir? Burhan? Javeria? Khadija? Aisha?
Sir, I said it's 0.
Okay, Javeria. Nobody else knows. So bad. It's wrong actually. So the thing is that because it is a vector quantity, what happened to my drawing? Where did it go? What really happened? Okay, something happened. Okay, never mind. So you guys need to understand that if it's a vector quantity, it means if I take this side as negative, I have to take this side as positive. Do you understand? Which means then this would be negative, this would be positive. Now, the initial momentum will be equal to minus mu. and the final momentum will be equal to plus mu. So the change in momentum will be plus mu minus mu. So it is going to be 2 mu, not 0. Is it clear?
Yes, sir. Can you repeat?
You see, whenever we're dealing with vector quantities, I told you that you have to take a direction. If I take right side as negative, so the left side has to be positive because it rebounds. So if if it was going towards right, I took it as negative, then when it rebounds, the direction will be positive. Do you understand? So when you put it in the formula, right? So final momentum minus, and the initial momentum is minus. So minus and minus will be plus, so it will be mu plus mu, which is basically 2 mu, not 0. Understood?
Yes, sir. Thank you.
So always remember to check the directions. Now some of them, basically this will give you a sort of a graph as well. So suppose if we want to plot this, so change in momentum graph is going to be something like this. For some reason now my page orientation has shifted to the right. I don't know why and who did it. So angry at it. Doesn't really shift back. Anyway, so what it means is that actually initially, if this is momentum in Newton second and this is basically time, so this was going at minus mu, and then for some some time it would have shifted, like rebounded, and between that rebound time it has shifted to a new momentum which is mu. So now it is going at that. Do you guys understand this?
So can you repeat?
Like if you look at this object, right, its momentum is minus mu till it hits the wall. So at this point you see it goes till this is the point. From here, say from here till here, it is basically the contact time. Do you understand? So it is touching the wall, and then due to the force from the wall it has reversed its direction. So when it comes back, it is like the final momentum is mu, which is right here. Now it goes with mu. Do you understand?
Yes.
Okay. So now if they were different, then of course there would be a different graph. For example, sometimes you also have a, say, kinetic energy is lost or changed into other forms. So in that case, what would have happened was that if it was going at like straight line, and then it would have gone to a different velocity after the collision. So it was mv. So what we need to understand is that this graph that shows here is the one with the kinetic energy before is equal to the kinetic energy after, but here the kinetic energy before is definitely greater than the kinetic energy after. Do you guys understand? That's why its velocity is different and smaller. Any questions? So it really depends on the situation. Right now, because it's rebounded with the same velocity, that's why the first graph is basically showing the situation. But if it had lost some velocity, slowed down a bit, then we would take a different velocity and smaller one than before. Okay, is it clear, everybody? Any questions? Please let me know. Now let's talk about the next thing, which is called impulse. Can you hear songs in the background?
No.
Okay, that's great. All right. Now, the impulse is basically defined as the product of force and the time for which this force acts. Now, as you can see from the example here, there was a force acting that led to change in momentum. And if I multiply force with respect to time, so basically it will give me the change in momentum. Okay. So now I can expand this. I can write, okay, force into time is change in momentum, and it would be mv minus mu, right? Now check this out.
Sir, I don't.
Yes.
Sir, how the product of force and time is changing momentum?
Okay, let's suppose if right now you're sitting on a chair, right? So if I just apply a force for a split of a second on your chair, would you fall?
Yes.
Like I just touch it like this, just push it a little. What I'm saying
No.
is, if you apply a force for a considerable amount of time, the chair is going to topple. Do you understand? So, to bring, a change in momentum, you need to apply the force and for some amount of time as well. Do you understand?
Yes, sir.
So, what is impulse? It says that the product of force and that time you're actually using to apply that force basically brings change in momentum. Do you understand?
Yes.
Now, this means that this product F times T is equal to change in momentum, and change in momentum is mv minus mu. So, if I want to just find the force, so the force will be mv minus mu over T. Do you understand this? I just divided time there. Because the mass of the object is same, can I take mass common? So it will be v minus u over T. Do you see a formula here? Any formula you remember? No one remember this? Acceleration is change in velocity over time. So you can replace this. It means that the force is equal to ma. Anybody remembers this?
Yes.
Yes, sir.
So basically what we've learned from doing all this is that we learned a very important lesson. First of all, we have actually learned the definition of a force. And now force will always be defined as the rate of change of momentum. There is no other definition of the force. Please remember this. You need to always write this. Also, this is what we have learned from Newton's second law. So Newton's second law says, basically defines force, and it basically tells us that a resultant force is the rate of change of momentum. So this is what Newton's second law is, which is resultant force is rate of change of momentum, which translated into F equals to ma. That's why we learned this formula. Is it clear, anybody? Everybody? Any questions here?
No, sir. No, sir.
Now, interestingly, you might be surprised that Newton's second law basically came first, then Newton's first law. So why did he name second law as second law and not the first law? Because the first law was needed to explain what he meant by resultant force. Okay, so what he means by resultant force is that an object will continue to move at constant speed in a straight line, or stay at rest unless a resultant force, that we sometimes call the external force as well, resultant force acts. Do you guys understand this? So
Yes.
there must be a resultant force. So Newton's second law came first, but to explain it, he had to make first the first one. Now, just write a note here so you guys remember what I mean. And remember, the direction of acceleration of a body is always the same as the direction of resultant force. Any questions?
No, sir.
Now I want to, you please write this down, then I'll just go forward. Right. All right. So done? Should I go forward?
Yes, sir. Yes, sir.
Now I want to bring your attention towards the previous graph right here that I basically intentionally left half of it. Now, you see, if this is the contact time that I've talked about t, so where would basically the force acts on the ball when it was hitting the wall? Oh, sorry. I only answered that too. So the force is responsible to change its direction. We just learned and change the speed or whatever. So what, when it hit the wall, there must be a force between them, right? So wall must have, applied a force on the ball that would have caused it to move in the opposite direction. Do you agree? So if you look at this section where it is the dotted line, right? Do you agree that this is the time where force must have been applied, right? Now, if I find the change, like the gradient of this line, so the gradient of this line would give me mv, sorry, the change in momentum. How do I know this? Because the gradient would be like mu minus mu. Do you guys agree? And because on the x-axis rise over run, so the change in time is t, so change in time is t. So basically you see that the gradient of this graph that we have just done basically represents the resultant force. Any questions? Do You guys understand now? Right. Now, so now let's move a bit forward. So, why is this so important? Because we need to understand that this force that we're talking about is basically change in momentum upon time. If the change in momentum is the same, then we can compare force and time. So, we can say force is inversely proportional to time, which means that if something takes a larger time to change in momentum, it means the force is going to be smaller, and vice versa, right? So let's just take an example here. Do you guys visit Pakistan often or no?
Yes.
Do you know which car is Pakistan's favorite? Don't tell me you don't know.
I mean, there could be multiple Mehran, Alto, City. Which one?
Mehran is Pakistan's
Okay.
favorite. Okay. You know why Mehran is so favorite? Because it reduces Pakistan's population. It has kept a check on it. The reason is that Mehran has no airbags. And not having airbags is a big problem. I'll tell you why. Because it can simply kill you if it runs into an accident. So, suppose that the man that is driving this Mehran, it has no airbag. This car is traveling at a velocity of 30 meters per second, and when it crashes for only 0.2 seconds. Okay? The mass of this person is 80 kg. Okay. And similarly, there's another person who's traveling. I don't know what is really happening. I took my iPad to school today, and these kids, must have done something that has messed it up for some reason. Look at this. What is happening? This. Oh my god. Probably I need to restart it after this class. Okay, it's clearly not doing anything. It has some problems now. Okay, I'll draw it anyway. So this car, suppose, has airbags. Okay. The man is the same with the same mass, but this crashes for it takes 2 seconds, because when it crashes, it also opens the airbags. Is it clear, everybody? So if I try to find the resultant force here, so mv would be 0 in both the conditions because it completely stops. Mu would be 80 times 30, that is going to be 2400 Newton seconds. Same Mu would be 80 times 30, that is going to be 2400 Newton seconds. Now if I want to find the force, so for this momentum you got to divide 0.2, so that's going to be 12,000 newtons on the man, whereas on this one it is going to be only 1200 newtons. Who's gonna die basically? Yes, bacho.
Left.
Left, because that person basically airbag does not basically change anything to the momentum. Basically it increases the time to change the momentum, and if the time to increase the to change the momentum increases, that means that actually the force overall reduces. Any questions?
No.
Very good, excellent. All right, now, so one of the most recurring questions about this in paper 1 would be, let's do an example. Oh, by the way, when the meeting ends, you guys need to rejoin, okay? So it says water is pumped through a pipe at rate of 90 kg per minute. It emerges horizontally with a speed of 20 meters per second. Okay. So he says, which force from a person holding the pipe to prevent it moving backwards is required? So this is the question. Now, when they say pipe at a rate of 90 kg, so you need to basically take out some of the things from this. Like, for example, we need to know that the mass is 90 kg, and this 90 kg is coming out at a time of 60 seconds, because it says 1 minute. The initial velocity must have been 0, because the water must have started flowing, and the final velocity when it goes out of the pipe is 20. Now it says what is the force required. So it's pretty now simple. What you're going to do is you're going to find force is the change in momentum over time. The mass is like 90. The final velocity was 20, initial velocity was 0, and the time was 60 seconds. So when you solve this, this is going to come out as 30 Newton is the force required to keep it moving backwards. Is it clear, everybody? All right. Okay. Now, is there any question in this? Please let me know. Okay. The last thing I want to discuss with you is basically graph of change in momentum versus time, conversion to force versus time. This is very important to learn. So suppose that you have a graph given, which is like momentum, Newton second, and the time in seconds, and they have given you just this line. So you guys need to understand that if you find the gradient, like I've told you before, it would be change in momentum over change in time, which basically tells you about the force. Now, if they say, okay, draw a similar graph, like a corresponding graph between force in newtons, time in seconds. So what you're going to do, because the gradient doesn't change, it means that this line would be like this. Is it clear, everybody? Because the force is constant. And if you want to find, like if you basically find the area under the graph, that would basically give you force times time, because that's the area, and which depicts the change in momentum. Everybody understands this?
So this red line is just the gradient we got for the first graph?
Yes. And force times time graph, area under the graph will always give you the change in momentum. All right, any questions?
No.
All right then. So I believe that's it then.